We're going to cover conics fairly quickly, more in less time than you did in Algebra 2, just because most of you have seen this before. So the thing that is similar about the circle and the ellipse is you still have the x minus h squared and you still have the y minus k squared. Those are going to be consistent in all four conic sections. The ellipse will have some type of numbers in the denominator. If you don't have a denominator, that will be an understood 1. Okay, so the ellipse is going to have some numbers in the denominator where a circle does not, and also an ellipse is always going to be equal to the number 1 when the standard form of a circle is always equal to the radius squared. So an ellipse will have a center just like a circle does. You're going to change the sign of the h and the k when you pull them out of the formula, just like you do with a circle. You're going to take the square root of the a squared. You're going to take the square root of a squared, which will be an a value. And if that number is under your x, once you take the square root of it, that's how many units you move left and right. Then you'll take the square root of the number that's underneath your y. So the square root of b squared is going to be b. And because that number is under your y, once you take the square root of that number, that's how many units you move up and down. And that's all you use to graph your circle. You use your center, your ellipse. You use your center, you use your a values left and right, and you use your b values up and down. In this section, the textbook is going to talk about foci, F-O-C-I. We are not finding foci. We are just, if we had some extra days in the semester, we would find the foci, we would do all kind of extra stuff, but we don't have any extra days. Okay? So anytime the book says something about foci, you can just ignore it. All you need to do is find your center, your a value, and your b value and be able to sketch the ellipse. So let's look at some examples. We're going to start with number 2. These will already be in standard form. So again, you need 3 things to graph your ellipse. You need the center, you need the a value, and you need the b value. So what's the center of this ellipse? 0, 0. Square root of 25 is 5. It's underneath the x squared, so that I move 5 units left and right. Then I take the square root of 36, which is 6. And because it's underneath the y, that's how many units I move up and down. And then I'll sketch my ellipse. I probably wouldn't even use graph paper for these. I would probably just have my work on my notebook paper and sketch my graph out beside it. But you can do whatever you want to do. Anytime the a and the b value are really close together, your ellipse may look more like a circle, okay? But it is going to be a little bit longer up and down than it is left and right. So when it's a little bit longer up and down than it is left and right, we call this a vertical ellipse. It's not extremely important that you know that, but they could ask you for the domain and the range. I think you should be able to do that by now. All right, let's squeeze the next one in right beside this one. All right, number 8 is x squared over 9/4 plus y squared over 25/4 equals 1. So again, what this textbook likes to do is it really likes to start with conic sections that have centers at 0, 0. And it kind of does that sets the problems up the same all the way through all 4 conics. So this is just showing you that you could have some denominators that are not whole numbers. Usually you have whole numbers, but you don't have to have whole numbers. So this ellipse would have a center at 0, 0. What's the square root of 9 fourths? 3/2. So we're going to move 3/2, or, I don't know why I wrote 3/4. 3/2, or I might change that to 1.5. And since that's underneath your x, we're going to be moving left and right. 25/4, the square root of that is 5/2. And that's approximately, or not approximately, it's 2.5, and that's how many units you're going to be moving up and down. Again, this ellipse is going to be considered vertical because it's a little bit longer up and down than it is in left and right. Could be horizontal, just depends on your denominators. Alright, so we wish they could all be this easy already in standard form. Center at 0, 0, but you know they're not going to all be this easy. So let's look at one that's not in standard form. So this is a good time to start talking about how you know you have a circle and how you know you have an ellipse if the equation is not in standard form. So if you have something like 9x squared plus 4y squared equals 36, you're going to know that this is not a circle because the 9 and the 4 are different coefficients. Okay, if this were a circle and you had a 9x squared, then you have to have a 9y squared. Okay, for the circle to come out even in all directions, the two coefficients would have to be the same, and they would have to be positive x squared and y squared. An ellipse is going to have two different coefficients. That's what's going to make it longer left and right versus up and down or the other way. So the only thing I have to worry about here is, anybody know why I don't have to complete the square? There's not a little y to go with my y squared, and there's not a little x to go with your x squared. That's how you know you have to complete the square. So I don't have to complete the square here. All I have to do is make that 36 turn into a 1. So this is where you divide everything in the equation by 36. This one's pretty easy. The 9 should divide down into 36 evenly. It should most of the time. Okay? So you're going to get x squared over 4 plus y squared over 9 is equal to 1. And that would be considered standard form for your ellipse. And then you could locate the center. The center would be at 0, 0. You would move 2 units left and right and 3 units up and down. And you would sketch out your ellipse. So all of these ellipses so far have been vertical. They're not all vertical. All right, let's squeeze 18 in at the side here. All right, with all conic sections, the circle, the ellipse, and the hyperbola, you're going to have an x squared and a y squared. The parabola is the only conic section that doesn't have an x squared and a y squared. Circles and hyperbolas and ellipses all have x squareds and y squareds, and they always need to be on the same side of the equation. So the first thing that you probably want to do with number 18 is you want to move that negative 5y squared over to the left-hand side and get your x squared and your y squared terms on the same side. That's going to be true for circles, ellipses, and hyperbolas, because all three of those will have an x squared and a y squared. The parabola will either have one or the other, but not both. You'll have to do something a little bit different with the parabola. So again, I'm not going to have to complete the square because I don't have an x term and I don't have a y term. So all you have to do here is make the 30 turn into a 1, and you do that by dividing everything by 30. Then you get x squared over 5 plus y squared over 6 is equal to 1. The center of your ellipse would be 0, 0. You're going to have to ask your calculator for a little bit of help to find the square root of 5 and the square root of 6. So square root of 5 and square root of 6. Somebody give me some to the nearest tenths on those. 2.2 and 2.5 or 4? 5? Is that right? Now this ellipse will be really, really close to looking like a circle, but if we really zoomed in, we would see that it's going to be a little bit longer up and down than it is left and right. As long as you've written 2.2 and 2.5, if your graph is not just perfect, it'll be okay. All right, you will have a couple problems where they're going to give you the graph and you have to give them the equation. All right, so the next two examples are they give you the graph and you give them the equation. So number 20, so they're going to give you the graph. So here's our first horizontal ellipse. It's not perfect by any means, but you're going to, it'll be on a graph for you so you can locate the center. And what's the center going to be at? 0, 0. So they're going to give you the graph. That's given. So if your center's at 0, 0, then you know you're just going to have x squared plus y squared equals 1. And then you'll just have to determine what the denominators are going to be. So to determine what goes underneath the x squared, you count what? Left and right. How many units are you going left or right? 4. And you square that, and so you have a 16 underneath your x squared. Then to figure out the number that goes under your y, you count up and down. You go 2 up, 2 down. 2 squared is 4. All right. We'll do one more where they give you a graph. The center is not going to be at 0, 0. So they give you the graph. You give them the equation. Anybody still looking at 20? All right, 24. They're going to give you the graph. Again, it'll be on graph graph paper, and it'll be a little bit easier to see than what I'm doing. So again, they're going to give you the graph. You're going to look at the graph. It's going to be better than mine. You're going to locate the center. Where's the center? -1, -1. So you're going to have x plus 1 binomial squared plus y plus 1 binomial squared is equal to 1. So you'll use your center to get that part, and then you'll use your graph, count left and right, square that number. Left and right squared is 1. Up and down squared is 4. All right, 3 more and then we're done. So my 2 people that did not have honors geometry, Christina and Cole, did y'all do conic sections? You did not do conic sections, Cole? Did you do conic sections? You don't remember. Okay. All right. Well, I'm going to go a little fast, but I am teaching you everything. I'm not leaving anything out. All right, 38. All right, back to graphing. So 38, then your textbook is going to move to some equations that do not have the center at the origin. And then we'll look at 2 more examples where we have to put the equations in standard form. So this one's already in standard form. Got your nice little binomial squareds. Got your nice little denominators. Everything's set equal to 1. Everything's beautiful. On your test, some of your equations will be in standard form. Some of them will not be in standard form. I will not tell you what is what. It'll all be jumbled up. We'll get to practice all that on Thursday. So what's the center of this ellipse? +1, -2. We're always changing the signs of the numbers when we pull them out of the parentheses. That's true for all 4 conic sections. We're going to move 4 units in what direction? Left and right. And we're going to move 3 units up and down. And then we're going to sketch out our ellipse. If you don't like sketching these out, you can use graph paper, but I don't care if your graph's not perfect. Just make sure that you sketch your work down. All right, last 2. Last 2 are not going to be in standard form. One's not going to be so bad. The other one's going to be the worst it can possibly be. So let's look at 50 first. 50 is the one that's not so bad. So again, one of the things that you're going to have to do once we cover all 4 conics is you're going to have to identify the conic section. And right now, you do have an x squared and a y squared, even though they're part of binomials. And the coefficients are different. They're different because you have a 36, and then you have an understood 1. So that's what's going to tell you that you have an ellipse and not a circle. So anytime your x squared and your y squared term are both positive, but your coefficients are different, that's going to tell you whether you have a circle or an ellipse. This is an ellipse, but my equation can't equal 36, so in my next step I need to divide everything by 36. I didn't have to complete the square because they already had those nice little binomial squares for me. Alright, so I'm going to end up in standard form as x plus 4 squared over what? Understood 1. And then I'm going to end up with y plus 3 squared over 36. And then all that's equal to 1. So there's my standard form. Once you're in standard form, you can say that the center is -4, -3. We're going to move 1 unit left and right, 6 units up and down.
You said we don't have to graph these?
You do have to graph these. I do, but not right now.
Okay.
All right, left and right. 1. Up and down 6. All right, mine's not perfect, but y'all get the idea. All right, last example is 52, and it is just way, way, way out of standard form, and this is where we're going to have to use the algebra and complete the square and do all that kind of stuff. This is our last example. Everybody have number 50? Again, if they ask you for the foci, you're just going to ignore that part of the directions, and you're just going to put the equation in standard form and graph. So, we don't want to be in blue. So we're pretty well going to do the same process that we did in the circles, okay? Except there's a little extra step that you're probably going to have to do in the ellipse every single time. And that's because you can't complete the square until the 4 is factored out of the 4x squared. And you can't complete the square until the 9 is factored out of the 9y squared. So that's something you're going to have to do with the ellipse. So let's group our terms. So we're going to have 4x squared, and then we'll have the minus 32x, and then we'll have the plus 9y squared, and the plus 36y. We'll send our constant to the other side, and it will become a negative 64. So we're grouping our x's to get ready to complete the square. We're grouping our y's to get ready to complete the square, and we're sending our constant to the right-hand side. When you complete the square, okay, you cannot complete the square unless you have an x squared all by itself. You can't complete the square unless you have a y squared all by itself. So in the next step, with your x's, you're going to have to factor out a 4. And this is the step a lot of you will think that you can just skip. And this would be the step that I suggest that you not skip. So before you can complete the square, you have to have just a plain x squared. And you have to have just a plain y squared. The 4 and the 9 don't go away. They just go out to the left-hand side. And then when I divide by my constant term in a minute, the 4 and the 9 will divide down into some number that will end up being in the denominator. Okay? Now you use the negative 8 to complete the square. So what's negative 8 divided by 2 squared? 16. So you'll write plus 16. That's going to give you a trinomial that will factor into a binomial squared. Then you use the 4 to complete the square with your y. So what's 4 divided by 2 squared? 4. Every time you complete the square, the next step is to balance. So let's see what you added. You added a 16, but did you really add 16? No, you really added 64, because you really added 4 times the 16. This is going to happen in most situations when you're doing the ellipse. So if you added 64 on the left, come over here and add 64 to the right. Look at the next number you added. You added a 4. Did you really add 4? Nope, you really added 9 times 4, so you really added 36. So you got to also add a 36 to the right-hand side. If you want to say you added 64 and 36 and then come over to the right-hand side and add 100, you can. However you want to do that, but you got to add a total of 100 on the right-hand side. Any questions about that step? All right, so you're going to keep the 4. And then what are you going to do next? Factor the perfect square trinomial. So the square root of x squared is x. Bring down the sign of the middle term, which is minus. That's all you're taking from the middle term is the sign. The square root of 16 is 4. So the trinomial factors into x minus 4 squared. Keep the 9. How does the trinomial with the y's factor? Y plus 2 squared. Then on the right-hand side, I'm going to quickly cancel the negative 64 and the positive 64. And so the right-hand side, all three of those numbers combine to be 36. And since this is an ellipse, it can't equal 36. It has to equal 1. So then that's the last step, is you're going to divide everything by 36. So standard form is going to be x minus 4 squared over 9 plus y plus 2 squared over 4 is equal to 1. You can get decimals in the denominator, but we don't usually get a lot of those. So if you end up getting decimals in the denominator, it probably means that you did not balance correctly. So if the 4 doesn't go into the 36 and the 9 doesn't go into the 36, probably you didn't balance correctly. You can go back and check. Center of the ellipse is going to be at 4, negative 2. We're going to move 3 units left and right and 2 units up and down. And then you would sketch out your ellipse.